Welcome to Chip Logic Studio. In this video we will discuss about architecture and test plan. So whenever we are making any environment in any company for checking any duty, we will make an architecture. Whenever we are planning to make any building, we make architecture, a future plan that how our building will look like. Similar to that, we also make an architecture that how our test plan will look like. So we will see our two type of architecture here, SystemVerilog and UVM. If you understand SystemVerilog architecture, you can easily do your UVM architecture. So let's begin. Our first architecture is SV architecture, and in SV architecture or in any architecture, our first is our top module. And why it is module? Because it is static entity and everything will be inside this module. And in SystemVerilog and in UVM there should be a static module which will be here for entire simulation. Like if we are using the class, it will be in runtime, it will be created and destroyed. So what is the first necessary? That we should have a module like this. Inside that we will have our duty and connection between duty and top module. So what are the three things we are having in our environment? Inside the top module is our duty, interface, and our package or any class which contain all the outside information. For example, if you are using tick defines and any global data type, for example, so we will also include that as well inside our top module. After that, anything is our class. Anything like test, environment, active agent, everything is class. Okay, except duty, because duty should be module because it is static entity. Now, and interface is also static entity, and interface is like it is normal module and not a duty. Its name is only interface. Okay, so it will interface between duty and environment. And for connecting dynamic entity to the static entity, there is another concept which will I cover in our next videos or upcoming videos. So only focus is here about the environment. So the next class is our test class, and test class will have configuration and our environment in these two classes. Okay, so and we will go inside the test. There will be our environment, and in environment there can be an active agent or passive agent. It is not that every time there will be active agent or passive agent, but for teaching you about how active agent and passive agent are different, I have included both. Now, active agent has both these three things: generator, driver, and monitor. Passive agent doesn't have this generator and driver, it has only monitor, and this coverage and scoreboard can be outside of this agent. Okay, so there are two agents now. We can say agent 1, or you can say agent 2, you can name anything. So these are the types: active agent and passive agent. And after that we will have our generator, which will generate our sequences or any packets which will go to the driver. Now how it will go from one class to another class? With the help of mailbox. Now here mailbox will be of infinite length, and you can study about mailbox in the SV concepts. So communication medium is our mailbox, and it is one directional. We cannot send packets from driver to generator. We can only be sent it by generator to driver. Now from driver to interface there is one interface called virtual interface, and the packet will go from driver to interface. Then interface will send this data to duty, and duty will process this data. Up till in the driver it is our expected data, and after that duty is processed, it is our actual data. So our actual data will be taken by the input monitor, or either it can be output monitor, but the main case is monitor will take the data from the interface. And when the monitor will take this data, it will send to the mailbox, to scoreboard or coverage, whatever class you need for scoring or calculating the functional coverage or code coverage. Okay, so where is our data? From driver to interface, interface to duty, and duty to monitor, and monitor to coverage and scoreboard. So this is whole picture about the architecture. There is one module, inside that there are everything is a class except the duty and interface, and this interface will connect from our classes to our module, means dynamic entity to the static entity, and inside there are our generator will generate the packets, driver will drive the packets to interface to our duty, and duty will process the data, will be taken by the monitor, and then it will be compare with the score mode or calculated with the function coverage. This is all about our SUV architecture. Now final our architecture is our UVM architecture, and here is also the same case. Duty will be top module will be our module, duty will be always our module, and interface will be interface. Now in previous architecture I haven't shown you this, the interface will be like this, and this will be your virtual interface, but this is our concept or topic for another video, so we will not cover this. But rest of the thing is like similar to the SV architecture, like active agent, here is our passive agent. Now here we have used scoreboard outside of the agent, and you can do that for comparison, and from this monitor to this monitor the comparison is done in this scoreboard, and in scoreboard we have written our functional coverage and checker. So you can change inside of the environment class, you can do any changes like however you want, but mostly sequencer driver on monitor, or in SV generator driver or monitor will be on one agent. Rest of the thing you can just manipulate however you want. Now what is change in UVM architecture? Here is the change. These two things is the major change in SV architecture, UVM architecture. Okay, so virtual sequencer, I have made the video for virtual sequencer and sequencer. Okay, so you can watch that video.
It's my name,